All right, looking at worksheet A for chapter 2. So looking at 9 through 21, so a couple quick reminders on this one so we can speed through the first few problems because there's a lot of repetition here in the first few. So we got a quadratic formula up here. Keep in mind that what is under the radical that you're seeing here in red is what they call the discriminant, and the discriminant helps determine how many solutions there are. So any case where you have two solutions like this this function here, we know that the b squared minus 4ac would have to equal a positive number. Anytime you have one solution, also known as two equal solutions, that's when b squared minus 4ac equals 0. And in a no solution case like this one, the b squared minus 4ac is a negative number. Keep in mind also, as we're going to refer to here in the first question, that a solution is also an x-intercept. So that's why for number 9 for part A, we can sub in a -2 for x in order to find p, because if -2 is a solution and this function equals 0, that means we're treating this as an x-intercept because y is 0. So that's why we can sub in the -2 for x and solve for p. So for the first case that we're looking at, number 9, all we're doing is subbing in the -2 for x. So we'd be looking at something like 7 times -2 squared. Make sure you put the parentheses around any number that you sub in, especially a negative, because it does affect the outcome of that. So plus p times -2. And then you got the -2 equals 0. So from there, all we got to do is solve for p. And so that's a pretty simple solve. So if we work that one out, so right here we'd be looking at 4 times 7, which is 28. 28 minus 2 is 26. And if I subtract the 26 over to the right, I'm looking at -2p equals -26. So we're coming out with p equals 13. All right, now that we know that p is 13, we can sub that back in here to then factor part B on this one. So looking at the function 7x squared plus 13x minus 2. So as far as factoring, you can use any method that you want. I'll show you the method I like, but you do whatever works for you. I know a lot of people use like a guess and check method. The way I learned it was I'm going to take the 7 and multiply it over to the -2. And now I kind of go back to the old method of saying what multiplies to be -14 but would add to be 13. And so that would tell me that my factors are x plus 14 and x minus 1. The 7 that I multiplied in, I now divide back out. So I divide it back out of each of my terms. I reduce if possible, so this one becomes x plus 2. And for this one, it can't reduce, so you take the bottom number and you put it in front of x. It becomes 7x minus 1. So those are my two factors. All right, moving on to number 10. So if you look at 10, 11, and 12, these all basically say the same thing. If you have two equal roots, that is the same thing as having exactly one solution. So those are always the cases where b squared minus 4ac equals 0. And this is a really popular IB test question, so this is a kind of a definitely good little group to know here. So for a case like this, if we just plug into the b squared minus 4ac and set it equal to 0, because we have two equal roots, plugging in for that, so we got the b squared. So remember, this is always a, b, c. So in this case, a is 1 since there's no number here, b is 1 minus m, and c is 16. So I'm doing b squared minus 4 times a, which is 1, so I'm not even going to put it in there, times c is 16, and I know that equals 0 because of the two equal roots. If we FOIL that out, so 1 minus m times 1 minus m, we're going to get something like this. And then I'm going to bring down, that would be minus 64. So we are again kind of back to the quadratic scenario here where we're solving for m. So just to kind of order things, I would say m squared minus 2m, and then if we combine those, I got negative 63 equaling 0. And you can solve that any way you like. You can factor it, you can use the quadratic formula, whatever works for you. But just in the interest of time, I'm going to move on to the next question. I know we can all solve from here and get our two solutions for m. Keep in mind that you are not finding the solutions for x, you're finding the solution for m. So that's why it's still possible to get two different solutions. These are not, again, x, these are just solutions for m. So keep that in mind. So moving on to number 11, pretty much the exact same thing. Again, we would just do b squared minus 4ac in order to solve, and we would set that equal to 0 since it says there are two equal roots. So this one's really not a whole lot different, so I'm not going to spend the time on that one. If you run into issues or if you have any questions, just come in and see me and we'll take a look at it together. For number 12, again, it says there is exactly one solution for x, but we are solving for k. So it's still possible for us to have multiple solutions, but they are putting a little bit of a limit on this one by telling us that k has to be a positive number. But if I take the same process, because there's only one solution for x, that means b squared minus 4ac equals 0. So remember that two equal solutions is the same thing as having one solution. So again, in this case, we're going to take our b squared, which is 2k. Always remember to use parentheses anytime you substitute into a formula, like the one that we're using right now. So I got the b squared minus 4 times a times c, and we know this equals 0 in this case because there's only one solution. So we're going to go through here and solve for k. So if we did 16 times 25, we're going to get 400. If I square this term, I have 4k squared. So as we continue to solve, add the 400, divide by 4, we got k squared is equal to 100, and if I square root both sides, typically we would say it's positive and negative 10, but this one specifically tells us that k has to be positive, so we would only use the positive 10 as our solution. Moving on to number 13, it says determine a and b, knowing that the two roots are 2 and 4, so keep in mind, if our roots are 2 and 4, that means the solutions are 2 and 4. Which means we have points on the graph at 2, 0, and 4, 0. Since this already equals 0, that's why I can sub this in for the x value. We have two unknowns. We don't know a or b, so it's going to take two equations to solve. So in the first equation, I'm going to sub a 2 in for x. So right here, if I had 2 squared times 2, I get 8. So 8 plus 2a plus b equals 0 is my first equation. Do the same thing with a 4, so 4 squared is 16 times 2 is 32. So I'm looking at 32 plus 4a plus b equals 0. We can solve this either with substitution or elimination, doesn't matter which one you want to use. I guess I would just use elimination since this is already set up for that with the b's. So I'm just going to subtract everything straight down and let those b's get eliminated. So if I did 8 minus 32, I'm looking at negative 24. 2a minus 4a is negative 2a. My b's would cancel. And now we have a pretty easy equation to solve for a. Add the 24 over, divide it by negative 2, and we figure out that a is negative 12. And then I can just plug that back in here for a in order to get b. Moving on to number 14. So right here, notice they're telling us on this function that we have a vertex at negative 6, 5. So automatically that tells us our values for p and q. Remember, anytime you do a horizontal shift, you always end up with the opposite sign that you would expect. So if we're going to the left, then I get a positive. So if I was writing my own function for this, I would call that x plus 6. So in order to have the negative right here, p has to be negative 6, so that you get x minus negative 6, since we would call this x plus 6 as our factor. So that's where the P is -6. And then as far as the Q, that's our vertical shift, and these guys are nice and friendly. They always do what you expect them to do. So if you go up 5, it is +5. So right there we got our values for P and Q. So at this point we now know those guys, so let me just sub those in. So again, right here you'd be looking at x minus -6, so I'm going to write that as x plus 6 plus 5. So the only thing we don't know is our a value, so that's where we can now use another point on the graph, like this one, to sub that in for x and y, and we can solve for a. So in this case, I know I have a point at 0, -1, so that means x is 0 when y is -1. So if we sub those in, and now we can solve for a. So if I subtract the 5 over, I'm looking at -6. And right here, 6 squared is 36, so 36a. And divide that over, and we have -1/6 for our a value. All right, number 15, so similar graph, but changing the question here. So they're giving us the function that was drawn over here. So they're calling the equation of the axis of symmetry L, and they want us to find the equation for that. So one thing to keep in mind is, remember what we talked about up above, your intercepts are also your solutions. So when we set this equal to 0 and solve it, it's already factored for us. So what would our two factors be, right? X and 7 minus x. If I set those equal to 0, I get my two solutions. So if I set x equal to 0, I get 0 as one solution. And if I set 7 minus x equal to 0, I get 7 as my other solution. So I know this point right here is at 7. The axis of symmetry is always the center of the graph. So it's got to be halfway between 0 and 7. So if I add those up and divide by 2, then I get 3.5 or 7 halves as the center of the graph, or the axis of symmetry. So it's got to split those guys down the middle. In order to get the y coordinate of that, then we would just sub that back in for x into the original function in order to get the y coordinate that goes with it. Remember, that's just an x coordinate, that's all that is. So we just sub that in for x in order to get a y coordinate. One thing to be careful of, and this is again always important on a test, is you got to answer questions exactly the way they say. So if it says write an equation for L, you have to write an equation. So if you just put 7 halves, you'd be marked down for that. You have to write the equation by saying something like L equals 7 halves in order to get full credit for something like that. So always read those directions carefully on a test to make sure that you do those right. So moving on here, number 16. So they've given us another quadratic function, and they want us to rewrite it into this form. And once it's in that form, we can then identify what is sitting in those places for a, p, and b. So on this one, we can just use a little completing the squared process in order to reformat it to look like this. So I got my 5x squared minus 5x, and I'm going to separate out my 9/4. Before you complete the square, you got to pull out this initial term. We don't ever complete the square with a number here other than 1. So I got to divide out the 5. So it's going to look like that. Now I can complete the square. Remember, to do that, we use the little formula b over 2 squared in order to complete the square. So my b term is -1. So -1/2 squared is 1/4. And remember, you can't add 1/4 out of nowhere. You have to keep the equation balanced here. So if I'm going to add something, I also have to take away something in order to keep this balanced. So what did we really just add? If I multiply the 5 into this parentheses, I just added 5/4, which means I also have to take away 5/4 in order to keep my equation balanced. Right? Everything is on the same side of the equation right here, so that's why if you're going to add something, you also have to take away something to keep it balanced. So now if we do a little cleanup on that, if we want to put this middle guy into factored form, we now know it's a perfect square. A little cleanup on the right. So if we subtract, I'd be looking at 4/4, which is 1. So we got that value. Couple different ways you could look at this. To put this into factored form, because it's a perfect square, you could either say it's the square root of this, which is 1/2, or you can say it's b over 2. Whatever is in this parentheses also becomes the factor here. So I can also write that as x minus 1/2 squared. So with fractions, sometimes it can be harder to tell what the factor should look like. So if you kind of keep that rule in mind, that's sort of an easy way of figuring out what should go here. So it's always b over 2. So in this case, negative 1 over 2 is what should go right there. So now we can easily identify what a, p, and b are. Keep in mind, as always on a test question, read careful. If it says identify what those are, you need to clearly state what they are. So we then need to say, literally write out a equals 5, p equals 1/2, and b equals 1. Keep in mind the negative was already there, so p is not negative 1/2, p is just 1/2. The negative is already there, so we're just identifying what is in place of p. So moving on to number 17. So giving us another function, we got a couple unknowns. They're telling us that x has to belong to the real number system, which really is not going to change what we are doing here. It crosses the x-axis at x equals 5 and at x equals negative 2, so figure out the values for b and c. One thing you always keep in mind whenever you're doing a quadratic is the idea of symmetry, meaning the curve that you're getting is always perfectly balanced to the left and to the right. So if my graph is crossing where x equals 5 and it has the vertex, which is the center of the graph, at negative 2, so if negative 2 is the center of the graph, then I can mirror this over to the other side to figure out where else my graph passes through. So since these guys are 7 units apart, I can also go 7 units to the left, which would put me at negative 9. And so I know I have a graph that will pass through these two guys. So it could be, so we're going to have a positive graph on this one. So I know I'm going to have something doing this. So it's going to pass through negative 9 and 5. This one was made nice and simple because a is 1. So remember that your intercepts are also your solutions, which come from your factors. So I would have a factor of x plus 9 and a factor of x minus 5 for this setup. And we don't have to worry about an a value because a was already 1. So if I just FOIL that out, I can see what numbers are sitting in place of b and c to state what those answers are. Moving on to 18. For 18, if we want to find the intersection of this parabola and this line, there's two ways you can do it. Can be done on a calculator. I'll show you that real quick in case we're in a situation where you can use a calculator. So if I go to y equals, so I already put those in. I can graph both functions. So I just put them in as two separate graphs. Hit graph, and the function comes up. And so all I'm looking for are the points of intersection for those. So if I go under calc and choose intersect, there are two scenarios here, so I'm just going to put my cursor near one of them and hit enter, enter, enter. And you can see right there we get our first point of intersection. And then if I go back under calc and choose intersect and put my cursor closer to the other one, so I'm just scrolling over to the right here and hit enter, enter, enter. Then there you go. We have our other point of intersection. So that's an easy way to solve if it's a calculator scenario. If you were in a case where you couldn't use a calculator because some test settings are non-calculator. So if that were the case, we would just set this equal to this and solve the equation. So if I set x squared minus 2x minus 7 equal to 2x plus 5. And we're solving a quadratic. We like those to equal 0, so I'm going to subtract 2x, subtract the 5, make this whole thing equal 0, so negative 4x minus 12 equals 0. So we could solve that pretty easy by factoring. So x plus So we got our two factors, so two solutions would be negative 2 and positive 6. And this one specifically called for points of intersection, which means we have to list these as ordered pairs or points. So I would plug -2 back in for x, pick an easy one. So I plug -2 back in for x in order to get a y value for him, plug 6 back in for x to get a y value to go with him, and we would group those as the x would go with its specific y value, so write that as an ordered pair. Number 19. So given a curve, find the coordinates for A, B, and C. So we can see those, all three of those are intercepts. And remember, intercepts always come from your zeros. So we can use that to figure those out. So if we were solving for A and B first, because they are x-intercepts, at those points we know the y coordinate is 0. So if I can plug a 0 right there in for y, then we're going to just solve that basic quadratic in order to get the x values for A and B. I would probably want my leading term positive, so I'd throw everything onto the other side. So I'd be looking at x plus 3 and x minus 1. So -3, +1. So we know those are our values for A and B. Obviously A is the -3 and B is the +1. So the only thing we'd be missing then is our C value, but he's on the y-axis. So when you're on a y-axis, that is where x is 0. So if I sub in a 0 for those two x's, well, all that would leave you with is y equals 3. So there you go, we got our C value. Number 20, so intersection of two parabolas, real similar to what we did on number 18. You do have the option of graphing. If it's a graphing setting for a test, and you're allowed to use the calculator if it's that portion of the test. So I could graph them both, calculate the points of intersection just like I did on number 18. We could also do it by hand. If we were going to do something like this, it's probably a by hand situation anyway, so we're just going to simply set this equal to this since we're looking for where they intersect, and then we just have to solve that equation for x. So we got the 1/2 x squared. This guy is equal to this guy. First thing that I would probably do is just multiply through the entire equation by 2 in order to get rid of my fraction. I'd rather not work with the fraction. So if I multiplied everything by 2, this is the setup that I would want to work with. So that's much friendlier to deal with, so I'm going to subtract everything over to the right. So if I subtract x squared, that is now 1x squared. Add the 2x, you now have 8x. Subtract the 12, you now have -20. And from here, just like the others, that would be a pretty simple solve. I would just factor that and get my solutions that way. So for the last one, number 21, we get a little different wording on this one. They're giving us a function. They tell us that there are 2 distinct roots. And so that just means there are 2 separate roots. So we're back into a case where there are 2 solutions to this. So we're finding all possible values of p. We're still using the discriminant, so I'm still going to do b squared minus 4 times a times c. And in this case, if we have two distinct roots, then this is a case if I have 2 solutions that my discriminant is positive. So it's got to be greater than 0 in order for that to be true. And these would have to be real solutions as well for this to be true. So based on that, if we started solving, so we'd be looking at 36p squared minus 16 times 9, which is 144. So if I add that guy over and then divide by 36, looks like we get p squared is greater than 4. So if I square root both sides, remember inequalities are a little bit weird. When I square root, typically we throw in a plus or a minus. Remember what happens to an inequality when you change the sign. It also changes this sign. So in this case, when I square root both sides, I get p is greater than positive 2, but less than negative 2. If we're going to do something like that. So that's just because it's an inequality, the sign flips when you throw in the negative. And that's it for worksheet A.